Okay, we're looking at, basically, I know it says arithmetic and geometric, but this worksheet is all about just arithmetic. Okay, so first of all, I know that looks like arithmetic, but it's not. It's arithmetic. So we put this emphasis on the etic part of our word. Okay, now some of this stuff might be brand new to you. So let's see, a sequence is just an ordered list of numbers. Okay, order matters. If order didn't matter, then we wouldn't have such things as the Olympics or rankings or the S&P 500, right? But it does matter. Okay, it matters whether you're first, second, or last. At least you competed. So here we have a list of numbers, a sequence. Okay, and these things use what we call subscripts. So if you've never seen a subscript before in your life, this will be an introduction to subscript notation. So a subscript is what's happening below. Like we have exponentials, they're happening above. That's a postscript. A subscript happens down below, right? So here's your normal letter A, and this is the first term, so we call this A sub 1. The first term in your sequence. And then the second term would be called A sub 2. You put a little 2 down there as a subscript representing the second term of your sequence. Okay, 4 is your third term, so A sub 3. You put a little 3 down there in your sequence, and so on and so forth until we run out of terms. Okay, so A sub 4 is the fourth term of your sequence. Right, so somewhere out here, we're going to have the random term. We call the random term the A sub nth term, A sub n. Okay, representing some random term somewhere out there in the sequence. Maybe it's the 45th term. Maybe it's the 32nd term. Maybe it's the 999th term. Okay, so this is what we're calling the nth term, also known as your equation. So we're going to write an equation to generate any of these terms. We're writing an A sub n or an nth term equation. Now here comes some even weirder stuff. The number after the A sub 1 is A sub n plus 1. Okay, so we can have a whole bunch of variables in your subscript which represent different numbers along your sequence. So if it's A plus 1 is a number to the right, how would we write a number to the left? A to the n minus 1 power. Actually, it's not a power, but it's the subscript n minus 1. Okay, and then n minus 2 would be the previous 2 terms ago. Or n plus 2 is how old you're going to be in 2 years from now. Right, so A sub n is like your now a day, and this is like what's happening tomorrow or the next day or the day after that. What happened yesterday, what happened 2 days ago, right? That n minus 1 subscript is talking about previous terms. If this is your current term, then n minus 1 is your previous term. Okay, if this is your current term, this is your previous term, the one that came before this. And then the A sub n1 plus 1, this is going to be your next term. Okay, so if you're not familiar with sequence notation, there is a little introduction into your sequence notation. Now notice on the graph, right, these are just a bunch of discrete points. They are not connected to form a curve or a line. Okay, we do not connect these on a dot. They are discrete terms. Right, we don't have the 3.5 or the 9.6. It's just the term in the sequence. Okay, so let's look at the formula. There is a formula for this, and we're going to use this formula a lot today. We're going to refer back to it and back to it and back to it. Okay, each successive term for an arithmetic sequence, this is good for arithmetic sequences only, has something called a common difference. If we subtract any two terms in your sequence, you're always going to get the same number. Okay, maybe each term is 2 units apart, or maybe each term is 7 units apart. Okay, that's your common difference. So we can write this formula very simply. It always occurs with the first term. The first term is a very important part. Okay, so this is our formula that we're going to use to write an equation to generate any term. So a sub 1, the first term, plus parentheses n minus 1. Okay, this is the formula part of your equation, times d, the common difference. Okay, so this is the equation we're going to use over and over and over and over and over today to find out different things. Okay, but that's our equation. So a sub 1, right, that's your initial value, your first term. I don't like calling it the 0 term because there is a 0, but that's not it. So a sub 1 is your initial value or your first term, and d is the common difference in between our terms. Okay, so that formula is a pretty important formula. I will refer back to it. You will use it on pretty much every single one of your problems. So as an example, write an equation, which is our rule, right? So we want an equation that represents this sequence. So the sequence is 2, 5, 8, 11, ... right? So this is going to be an infinite sequence because it has a ... It will continue in this pattern forever and ever and ever. So what am I doing to my terms in order to generate the next term of my sequence? I'm adding 3. 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 3 would be 14, and then 17, right? We're adding 3. This is your difference. Because if you, what's 5 minus 2? 3. What's 8 minus 5? What's 11 minus 14 minus 11? Right, so any two terms, the next one minus the one before it, that's your common difference. So let's write our formula. A sub n equals. Okay, anytime we're writing a formula, we write a sub n to notify us that this is our general term, our sequence. So we use the first term, which is 2. 2 plus, now here's our formula parts, n minus 1. Okay, that's always your formula part. Times, what is our common difference? It was a 3, so 3 goes there. Okay, sometimes you might see a formula where d is in front of here, that's fine, but putting d in the back means you're never going to mess up your PEMDAS. Okay, now let's simplify. Let's distribute our 3 into both of our terms here. 2 plus 3n minus 3. Okay, when we distribute both of those things, multiply by 3. And then when I simplify, 2 minus 3 is -1. So my formula is 3n minus 1. This is going to be my equation that I use to generate any term of my sequence. So now that we have our equation, we can figure out what is the 100th term of our sequence. So that's our n value. We're trying to figure out what is a sub 100. What is our 100th term? Okay, we're going to use our formula 3n minus 1 with an n value of 100. Right? We made that equation, so we're going to use that equation to figure out some other stuff. 3 times 100 is 300 minus 1 is 299. So 299 is the 100th term of that sequence. 299 is the 100th term. Right? You could have written out all the terms if you wanted to, right? You know the pattern, plus 3, plus 3, plus 3, plus 3. You could have added 3 another 92 times and gotten out to 100, right? But that takes forever. It's nice to have a formula that doesn't take forever. Okay? There we go. Let's see. You can write the equation of a sequence using any term, not just the initial term. Okay, and I guess this is the equation down there, right? It even tells you what it is. A sub k, right, where this is your kth term, where k is the nth term of your sequence, right? So this is going to be your formula that we can use to write the equation if we know any term of your sequence. And the difference, right? The difference is probably the most important part of your sequence that we need to do. So let's try this out. A sub n, for k equals 1, that means we have a sub 1, right, with a k value of 1. We write a 1 here. Plus, what is our difference? Is plus 3. We're using this term, 2 to 5, 5 to 8, 8 to 11. Our difference is 3 still. Now our formula part, n minus, what was our k value again? 1. So a sub 1 plus 3, as long as we know our difference, we can do this, times n minus 1. Okay, and then if we had a k value of 2, like it said, that's a sub 2 plus 3 times n minus 2, right? And so on and so forth. We can use this equation in case we don't know the first equation, the first value, right? You can still write an equation even if you don't know what your first term is. Okay, so there's some, here we get, there's number 3. Subtraction is still arithmetic. Yes, yes it is. It's adding a negative number. Okay, so let's look at this sequence and let's write an equation to generate all of our terms. So we have 7 became a 2, 2 to negative 3, negative 3 to negative 8. What is our common difference? Minus 5, right? It's a negative. We are subtracting each and every term. So a sub n equals our first term of 7 plus n minus 1, right? That's still the formula part. N minus 1 times negative 5. Right? So not minus 5, but times negative 5. So I put it in parentheses to remind myself that that is not a subtraction, but rather a multiplication. Okay, so simplifying, we're going to do some algebra. 7 plus negative 5n plus 5, because negative 5 times negative 1 is positive 5. So then when I combine my like terms, 7 plus 5 is 12. So my equation is 12 minus 5n. Right? That's my equation to generate any term of my sequence. 12 minus 5n. So just for fun, what would the 20th term of this sequence be? Well, that means it's 12 minus 5 times 20. 12 minus 5 times 20, right? If we want the 20th term, that means our n value is 20. 5 times 20 is 100. 12 minus 100 is negative 88. So negative 88 will be your 20th term of that sequence.